Welcome to Educator.com. Today's lesson is the first in a series of lectures on quadratic functions and quadratic equations. And we're going to begin by discussing graphing quadratic functions. The graph of a quadratic function is in a shape called a parabola. So first of all, talking about what a quadratic function looks like, or what the terms are that are included. The relation y equals ax squared plus bx plus c, where a does not equal 0, is the standard form of a quadratic function. A cannot equal 0 because if a does equal 0, this first term will drop out, and then it wouldn't be a quadratic function anymore. So here we have an x squared term, and that is what makes this a quadratic function. Without that, we would just have a linear function. We wouldn't have a quadratic function. Okay, some other examples would be of quadratic functions would be something such as y equals x squared plus 2x plus 3, or y equals minus x squared plus 1. Notice in the second one, I don't have a b term. That's okay though. I have just ax squared term and a c term, a constant. Because the only restriction is that a is not allowed to equal 0. However, b or c could be 0. Those could drop out, and you would still have a quadratic function. So this first one does have a bx term and c. This one does not. They're still both quadratic functions. Now, talking about the shape of the graph. The shape is a parabola, and this is a curve that either opens upward or downward. So it could look like this. Could be over here, could be down here. So it could be in different places. It can open either upward or downward. And the other feature of a parabola is that it can be broader or narrower. So these are a little broader. I could also have one that looked like this. And what determines whether you have a broader or narrower shaped parabola is the absolute value of a. So if the absolute value of a is larger, you get a narrow graph. So absolute value of a larger means a narrower curve. Okay, so for example, this would have a larger absolute value of a than something like this, that's broader. So in order to graph quadratic functions, we'll be choosing values for x and then finding the corresponding coordinates for y, just as we've done previously. And we're also going to be using some new techniques as well. Let's start out by discussing a little in more detail about the features of parabolas. As I mentioned, they can either open upward or downward. First, talking about parabolas that open upward. If a is greater than 0, then the graph opens upward. Recall that the general form, the standard form, is ax squared plus bx plus c. If a is greater than 0, this a term here is greater than 0, the graph will open upward. If a graph opens upward, then it's going to have a lowest point, which is called a minimum. For example, let's look at the quadratic function y equals 2x, or y equals x squared, just x squared, to keep it simple, plus 2x plus 3. So I'm going to go ahead and graph this by choosing points. I'm going to first note that a equals 1. That's going to tell me that this is going to open upward. So before I even start, I have the general idea in my mind that this curve is going to open upward. Now I'm going to choose some points so that I can make my graph. Starting out with x is negative 3. Negative 3 times 3 is 9. Plus negative 6 plus 3 would give me a y value of 6. If x is negative 2, here you'd get 4 minus 4, and that would leave you with 3. So I'm going through these a little quickly, but you can certainly work out each point on your own and prove to yourself that the math works out to give you the corresponding y value. But right now we're just focusing on getting the points and looking at the shape of this curve. Okay, if x is -1, -1 times 1, -1 times -1 is 1, minus 2 plus 3 is going to give you 2. If x is 0, these two drop out and you just get 3. And then finally, if x is 1, y comes out to be 6. So now I have plenty of points to go ahead and try to graph this. So when x is -3, I have to add another point right there. Okay, when x is -3, y is 6. That's my first point. When x is -2, y is 3. When x is -1, y is 2. When x is 0, y is 3. So now my curve's coming back up. When x is 1, y is 6. So the shape of this curve is like this. And you see that the lowest point is right here, and we call this lowest point a minimum. What it really is the minimum value for y. There's not going to be any coordinate that's going to have a smaller y value. This is as low as the y values you're going to get. These are all greater than that minimum. Now we're going to talk about parabolas that open downward. If a is less than 0, then the graph opens downward. Recall the function is in this standard form, and if you put it in standard form and you find that your a is less than 0, the graph will open downward. For example, y equals -x² minus 2x plus 1. A is right here. It equals -1. Since -1 is less than 0, this is going to open downward. Okay. Let's find some points. First, when x is -3, if you were to substitute in here and solve this out, you're going to find that y is -2. When x is -2, y is 1. When x is -1, y is 2. When x is 0, y is 1. A couple more points. When x is 1, y is -2. And finally, x is 2, y is -7. And you can work these out on your own, check them, find your own points by substituting in these x values and verifying the corresponding y value. Focusing on the graph, when x is -3, y is -2. When x is -2, y is going to be 1. So x is -2, y is going to be 1. When x is -1, y is 2. So we can already start to see the shape here. When x is 0, y is 1. So now the curve's coming down. When x is 1, y is -2. And finally, -7 is going to be right about down here. So when x is 2, y is going to be down here at -7. Okay, so I have enough points to get the general shape of this curve, and this demonstrates that this does indeed curve downward. So if you have a graph that opens downward, then you're going to have a point called a maximum, and this is going to be the maximum value of y. Looking at this curve, you can see that there is no point for y where y is going to have a larger value than it does right here. So a graph that opens upward has a minimum, and a graph that opens downward like this has a maximum. Now, the vertex of a parabola is its maximum or minimum point. And we just discussed maximums and minimums. And there is an equation for this. So if you have a function such in the form y equals ax squared plus bx plus c, you can find the x coordinate by using this formula, negative b over 2a. So this formula gives you the x coordinate of the vertex. However, if I've got a vertex, I'm going to need to find an x value and a y value. But once I've found that x value using this formula, then I can just go ahead and substitute that x into the function to generate my y coordinate. For example, looking at a function, a quadratic function, y equals x squared minus 4x minus 2. I'm always going to just want to have in my mind what this curve is going to look like generally. So I see that a equals 1, therefore a is greater than 0. So this opens upward. In this case, since it opens upward, my vertex is going to be a minimum, since it opens upward. Okay, so the next thing I'm going to do is in order to graph, is I'm going to find the value of the vertex. And I know that for the vertex, the x coordinate is given by the formula negative b over 2a. Looking at this quadratic function, my value for a is 1. My value for b is negative 4. So let's substitute these values in this formula. Negative b would give me negative 4 over 2a, so 2 times 1. That's going to give me 4 over 2 or 2. Okay, now you've got to remember what this is giving you, and it's giving you the x coordinate of the vertex. So I figured out that I have the x coordinate, and now I need to find the y coordinate. And the way I'm going to do this is I'm going to find the y coordinate of the vertex by finding the value of y when x is 2, or finding f of 2. So f of 2 is going to be 2 squared minus 4 times 2 minus 2, and that's 4 minus 8 minus 2 is going to give you negative 6, because 4 minus 10 is going to be negative 6. Okay, let's be really clear that the vertex, the coordinates for the vertex are x equals 2 and y equals negative 6. Okay, so when x is 2, y is negative 6. So if I have 1, 2, and then 1, 2, negative 1, negative 2, negative 3, negative 4, negative 5, and then down here, negative 6. So this is my vertex, and it is a minimum. Now I could certainly choose some more x values, generate those corresponding y values, and graph this out. But even with just the vertex, I have a very general idea that this is going to be a graph that's going to curve upward with its minimum y value at this point, at this vertex. And of course, to get a more exact graph, you would just need to find some points. So the vertex is very helpful in the graphing, because without it, you might end up with some points here and some points here, but you're really not sure where they connect. Okay, the axis of symmetry is related to the vertex because the axis of symmetry of a parabola is the vertical line that passes through its vertex. So we just talked about finding the vertex, and what the axis of symmetry is a line that passes through that vertex. The equation of the axis of symmetry for a function given in this standard form, a quadratic function in this standard form, is x equals negative b over 2a. And you'll notice that this is the same formula that gave us the x coordinate of the vertex. And that makes sense because this is simply a line passing through that where that vertex is. For example, if I had a quadratic function given as y equals negative x squared minus 2x plus 3, and I just wanted to do some graphing of it and find the vertex, find the axis of symmetry, I would start out by just looking that a equals negative 1, and since a is less than 0, this is going to curve downward. It's going to face downward. Okay? Therefore, it's going to have a maximum. The vertex will be a maximum, the maximum value of y. Okay, next I'm going to find my axis of symmetry. And that is going to be defined by the vertical line x equals negative b over 2a. Well, I just said that a equals negative 1, and I have b equals negative 2. Therefore, x equals negative, and that's a negative 2 for b, over 2 times negative 1. Or x equals 2 over negative 2. Okay, so the vertical line that goes through x equals negative 1, so x equals negative 1, and I'm going to have a vertical line right here, is going to give me the axis of symmetry. Now let's talk about why this is helpful. I'm going to find a few points, look at the graph, and talk about why we'd even, what is the point of finding the axis of symmetry and how can it help us in graphing. Finding some x and y values. Well, I said that x is negative 1, that goes through the vertex. So let's find our y coordinate for the vertex, and I would do that by substituting the value of negative 1 for x in this equation, and that would give me negative 1 squared would be 1. That would be negative 1 plus 2 plus 3, which would give me a y value of 4. When x is 0, these two drop out, and I get a 3 for the y value. When x is 1, y is 0. When x is 1, because I'd get 1 here, that's negative 1 minus 2 plus 3, so this would be negative 3 plus 3, that would give me 0. When x is negative 2, y comes out to 3. And when x is negative 3, y is 0. Okay, let's go ahead and plot these points. So first, remember this is my vertex because this gave me my x coordinate for my vertex. It also gives me the line for the axis of symmetry. So when x is negative 1, y is 4. So this is the vertex. And remember that I said that this is a maximum because it curves downward. When x is 0, y is 3. When x is 1, y is 0. When x is negative 2, y is 3. And when x is negative 3, y is 0. Okay, so I've got some good points to go ahead and plot out and draw my graph. And what this axis of symmetry is helpful for is, let's say that I only ended up with these points over here. I had picked just these values for x that gave me points over here. And I'd only have half my graph. Because it's called an axis of symmetry, what it means is that these two halves are symmetrical or mirror images. Therefore, if I had half the graph, I could reflect across to the other side and know that this side is a mirror image. So I have a point right here where x is 1, y is 0. And this is 2 away from this axis of symmetry. X is 2 greater than. Well, I could go over here and say, okay, 2 less than the x value right here, I'll also have a point. I could do the same up here. If I have a point on this right side, I can go ahead and find a point on the opposite side by knowing that I have a mirror image. So the axis of symmetry given by this formula can also help you with graphing. Okay, we're going to now do a few examples demonstrating how to form the graph for a quadratic function. I'm always going to recall or even jot down the standard form of a quadratic function. So I look at what I have, and it is in standard form. Then I say, okay, a equals 1. So this graph, this curve, is going to open upward. The next thing I'm going to do is I'm going to find the vertex. So the x-coordinate for the vertex equals negative b over 2a. I said that a equals 1, and I see that b equals negative 2 in this form, because it's in standard form. So that means that I'm going to have negative 2 over 2 times 1, which is going to equal 2 over 2, or 1. So my x value for the vertex is 1. To find the y value for the vertex, I'm going to find what y is when x is 1. In other words, I'm going to find f of 1. So I'm going to let x equal 1. So this is 1 minus 2 plus 1. So that's 2 minus 2, or 0. So f of 1 equals 0. So this is the y value for the vertex. My coordinates then are x is 1, y is 0. And so when x is 1, y is 0. It's a vertex. I know it opens upward, so I know this is a minimum. Now, when I go to choose points, I'm going to choose some points for values for x that are around this vertex. Because if I choose a point way out here or way out here, I can end up getting a point way up here, and it's going to be hard to figure out my graph because I have a big gap in between. So, and plus, these smaller numbers are much easier to work with. So let me go ahead and choose some x and y values. When x is negative 2, if you substitute in there, you'll find that y is 9. When x is negative 1, y is 4. When x is 0, then you're going to find that these drop out and y is 1. Let's see. When x is 1, we already did that. That's the vertex. When x is 1, y is 0. And then finally, when x is 2, y is 1. So this one's a little bit high up, so let's not, that one's off our graph. We'll go with the second point. X is negative 1, y is 4. But this does give us the general idea of how narrow or broad this graph is, how fast each change in x, how quickly y is changing. Okay, so we have negative 1, 4. We have 0, 1. We have 1, 0. This is the vertex. And we have 2, 1. Now, remember my axis of symmetry is right here. So if I wanted to, I could just reflect across and find this point here. I do also know that I have another point way up here, negative 2, 9. And this is my graph of this quadratic function. And I found this by finding the vertex using negative b over 2a, then finding the corresponding y value, and plotting some additional points. I can use reflection based on the axis of symmetry. And I also had another sort of double check, knowing that this should open upward because a equals 1. So a is a positive number. Okay, in our second example, we have y equals negative x squared minus 4x minus 4. So this is in my standard form, y equals ax squared plus bx plus c. And I have a negative value here, so a equals negative 1. So this opens downward. Next, I'm going to find my vertex. And the vertex equals the x-coordinate. The x-coordinate for the vertex equals negative b over 2a. I have a equals negative 1, b is negative 4. So that's going to give me negative 4 over 2 times negative 1. Okay. So this is going to give me a positive 4 over negative 2, which is going to give me negative 2. So the x value for the vertex is negative 2. Now find the y coordinate for the vertex by finding f of negative 2. And that's going to come out to, using this, negative 2 squared minus 4 times negative 2 minus 4, which equals, this is negative 4. Negative 4 times negative 2 is going to give me a positive 8 minus 4. So this is going to be negative 4 and negative 4 are negative 8, plus 8 is simply 0. So my vertex is going to be at negative 2, 0. And I know that this opens downward. So negative 2, 0, this is my vertex, and this is going to be a maximum. The maximum is at negative 2, 0. Okay, need to find some more points in order to graph this. And I know it's opening downward, so I'm going to go up here where I know that my graph is not going to extend into. When I choose points, I'm going to choose them in the area of the vertex. When x is negative 3, if I substitute that in and solve, y is negative 1. When x is 0, this becomes 0, this becomes 0, y is negative 4. When x is 1, then I'm going to get negative 1 minus 4 minus 4. It's going to be negative 9. And let's do one more point. When x is negative 4, y is negative 4. Okay. So my first point, negative 2, negative 4, negative 6, negative 8. So when x is negative 3, which is going to be about here, y is negative 1. Okay. When x is 0, y is negative 4. When x is 1, y is going to be all the way down here at negative 9. And when x is negative 4, y is negative 4. So as expected, this is curving, it's facing downward. And again, I found this graph by finding the x coordinate for the vertex, then the corresponding y value, and then graphing some other points around the vertex. And you could use reflection to find another point over on this left side. Okay. This example asks us to find the vertex and asks whether the vertex is a maximum or a minimum. Recall that the x coordinate, the x value for the vertex equals negative b over 2a. This is written in standard form, and I know that in standard form, this is going to be a equals negative 2, b equals 8. So it's just a matter of substituting in. So then I'm going to get negative 8 over 2 times negative 2, which equals negative 8 over negative 4, and that's 2. That gave me my x value. To find the y value for the vertex, I'm going to need to go ahead and find f of 2. And this is going to equal negative 2 times negative 2 squared. Excuse me, positive 2. That is a positive 2. So negative 2 times 2 squared plus 8 times 2 plus 15. So this comes out to negative 2 times 4 plus 16 plus 15, or negative 8 plus 16 plus 15. And this will give me a value for y that is 23. So I have my x value for the vertex is 2, and the y value is 23. Vertex equals 2, 23. Now, is this a maximum or a minimum? A equals negative 2. Since that is less than 0, the parabola opens downward. Recall that if a parabola opens downward, the vertex is going to give you the maximum value for y. So this vertex is a maximum. Okay, so we found the vertex. It's at 223, and we also answered the question that it was asking, which is that this vertex is a maximum. This time we're asked to find the equation of the axis of symmetry and then to graph the function. I'm looking, and this is in standard form, and the equation for the axis of symmetry is defined by the vertical line at x equals negative b over 2a. A equals negative 3, and here b equals 6. So I go ahead and substitute in those values. X equals negative 6 over 2 times negative 3. That's going to give you negative 6 over negative 6. This equals 1. So the vertical line at x equals 1 is going to be the axis of symmetry. Now I need to graph this. So a good start would be finding the other point for the vertex, and that is going to be, so for my vertex, this is the same formula for the vertex, x equals 1, and y equals f of 1, which equals negative 3 times 1 squared plus 6 times 1 plus 3. So this is going to be negative 3 times 1 is negative 3, plus 6 plus 3. My 3's cancel out, so the value of the vertex is going to be found at 1, 6. Okay, so that's up here. And I do know that since a is negative 3, it's a negative number, this is a maximum. The vertex is a maximum, and this parabola is going to face downward. It's going to open downward. I need to find some other values for x and y in order to complete my graph. And when x is negative 2, y turns out to be a pretty big value of negative 21. That's going to be way up there. And then when x is negative 1, y is negative 6. And what this shows is that when x changes one increment, y changes a lot, which is going to give me more of a narrow graph, and that fits with the fact that the absolute value of a is 3, so that's going to be a narrower graph than, say, if a was 1. Okay. When x is 0, that's 0, that's going to be 0, that's going to give me 3. I already have the vertex, so my value when x is 1, I know that y is 6. And when x is 2, y is 3. So you could solve that out, and you will find this result. Okay, so I'm going to leave this one off because that's too far up, but I can do when x is negative 1, y is negative 1, negative 2, negative 3, negative 4, negative 5. It's going to be right about here. So I have a point right there. When x is 0, y is 3. So when x is 0, y is 3. And you can see this is a pretty steeply curving. When x is 1, I already did that. Y is 6, that's my vertex. And when x is 2, y is 3. So as I said, we're getting a narrow curve because of that relatively large value for A, absolute value of A. And if I wanted to, I could reflect another value across right about there using my axis of symmetry to help me find this graph. Okay, so this time I found the axis of symmetry as instructed, and then I graphed the function by finding the vertex and then finding a few other points and then reflecting across the axis of symmetry. So today on Educator.com we discussed our first lesson on quadratic functions and then discussed how to graph those functions.